on working with congruent angles. The actual notes aren't going to take us all period today. You'll have time to start your worksheet. There's not a lot of new in here. So we are going to be talking about proving angles congruent, and we're going to be doing some more proofs. So starting here, let's remind ourselves, what do we know about vertical angles? What do we know about vertical angles? All right. There's opposite sides or opposite rays. That's right. The sides that make those angles, basically, if you have two lines that cross, the opposite angles are vertical angles. So these are vertical angles, and these are vertical angles. What do we know about vertical angles? How do they compare, Xavier? Vertical angles are congruent, right? Yes. So these angles will be congruent, and these angles will be congruent. Not necessarily congruent to each other, though, right? So it would only all be congruent if they were all 90-degree angles. So make sure you're adding your notes. So I actually get a grade for notes, and all you have to do is just write everything I write to get credit for, okay? And we'll scan them so that I'm on mine. If you ever scan them to anything on Canvas. Okay, I'll do that today. And we'll get to the minutes, okay? Okay. So here, vertical angles are congruent. Make sure you made a reminder of that. That's what we learned on Wednesday. So we know that this angle and this angle have the same measure. That's what it means to be, for angles to be congruent, means that their angles are equal. The measure of the angles are equal. So we know this vertical angle is 6x, and we know this vertical angle is 2 times x plus 24. And they ask us to solve for x, which I think they do on yours. It doesn't say it on mine. So we can write an equation where we set these angles equal to one another. So 6x equals 2x plus 4 would be the equation that we can write because we know these are vertical angles and we know the expression that represents the measure of each. So now we can write an equation. Oh, thank you. Forgot my 2. Okay, so once we have an equation, we can get the variables on the same side. We're going to subtract 2x from both sides. And we have 4x equals 24. To solve for x, this is 4 times x, so we're going to undo multiplying by dividing. And now we know that x equals 6. So we were able to write that equation. Close up your Chromebook, Sandra. Chromebook. Everyone's Chromebook should be closed up. Dallas, closing yours up. Darren, closing yours up. Thank you. Anybody have a question on how we found that x equals 6? All right, we're going to do the same thing with example 2. Two lines that intersect to form two pairs of vertical angles. The vertical angles that we're looking at have a measure of 17 plus 3 times x and negative 4 times x plus 31. So we're going to do the same thing. Mark them congruent. And let's use 2 arcs. The number of arcs doesn't matter as long as that this angle is supposed to be congruent to this angle, we use the same number of arcs. Okay? You know, you're supposed to I would not. It shouldn't have. I would have done it. Okay, so now we're going to write our equation, just like we did here. If they're vertical, they're congruent, and that means we can set their measures equal to one another. So these expressions represent their measure, and so we can write an equation where we set them equal to one another. We're going to get our variables on the same side. Remember, we look at the coefficient on the variable term that's the smallest, and we do the opposite. So negative 4 is smaller than 3. So we're going to add 4x to both sides. So 17 plus 7x equals 31. So I'm going to solve by subtracting 17 from both sides. 7x equals 14. We're going to divide both sides by 7. And now we know, for example 2, x would equal 2. If we wanted to know the measure of these angles, remember we can plug 2 in for the x. So 3 times 2 is 6, plus 17 is 23. So now we know the measure of this angle is 23. And if this was 23, then that has to be 23. If this angle is 23, does anybody know how to find the measure of this angle? What do we know about this angle? This, Xavier?
What I did, I found out that so I just subtracted. So I added.
Okay, you can go that way, am I right? Yeah, you can also just subtract the 22 from 80 degrees. This is a straight angle. These two are linear pairs, and these are supplementary. So literally 180 minus 23. Eyes open, everybody. I know it's 3 years after lunch, but I'm going to stay open. Adine, thank you. All right, so these, just because there's a segment here connecting those, doesn't mean anything different. We still can imagine that this is a line and this is a line that extends forever, and it still makes these angles vertical angles, and they're congruent. So these are in a box, doesn't matter. These are still 4 vertical angles. Just because that one is closed off doesn't make any difference to the measure of these angles. Okay, so don't let that stress you out. We are going to be using, and we're making our way using these angles or inside a rectangle or inside another shape. That's one of the things we'll be using that information. Dallas? Plug it into the expression. 3 times 2 is 6. 6 plus 17 is 23. We found out that x is 2, right? They didn't ask you to do that. I was just showing you another way of that. Once you get that x value, that's how you can use it. We know that if this angle is 40, what is the measure of this angle? 40. But they asked us not to find the measure of this angle, to find out what x is, right? So what do you think the equation would be? Miles, can you tell me what the equation would be? Perfect. 40 equals 3x plus 13. And now we solve for x. We're going to do the adding by subtracting 13 from both sides. So 27 equals 3x. 3 times x, remember. So how do we undo multiplying? Should all know it's dividing at this point. And so now we know that x equals 9. So these are the diagonals. Everybody kind of with me? Okay, so the last example here, example 4. We still have 2/3 of vertical angles, but they only give us the measure of these 2 angles. They are vertical angles. Remember, just because you don't see, because these segments that are the diagonals in this rectangle, they are part of lines that extend forever. These are 2 intersecting line segments just because it don't go on forever and ever, that doesn't affect the measure of these. These are still vertical angles, and they are still congruent. So just like up here, now we just set them equal to one another and solve for x. What's the first step to solve that equation? Elizabeth, can you come with me first? Subtract what? Perfect. Subtract. We got 2x and a 4x. The 2 is smaller than 4. So we're going to undo that. So now we have 24 equals 2x minus 16. Add 16 to both sides. Going through the steps of solving these two-step equations at this point. So we got something there. Divide both sides by 2, and now we know that x equals 20. If we were asked to find a measure of these vertical angles, we could take that 20 and plug it in either expression. 2 times 20 is 40, 40 plus 24 is 64. So now I know that both of those have a measure of 64. Make sense? Good, Morgan? Nadine, you good? Diane, good? Everybody caught up with me? Alright, so now we're going to use these concepts in some more proofs. Given information and the statement we're going to prove. So this statement, angle 6 is congruent to angle 2, is given information. It's a given statement. What we're going to prove, or we need to prove, is that angle 3 is congruent to angle 7. Or whatever you're proving should be in your last statement in the proof. The whole point is to prove this, but that should be the last thing. Does that make sense to everyone? So what is this statement that I'm going to uncover for number 1? What is that statement supporting? What is the given statement, right? The given statement. Go ahead. 2 and 6. Zion? Yeah, so see what goes behind the word given? That is what's given. That's your given statement. So we're going to write that in. If they gave us a statement, we would write the word given there. You're right what we're writing, aren't they? Can you see where we are? Okay. Let's look at our diagram. It tells us that angle 2 is congruent to angle 6, and they wanted us to prove this angle is congruent to this angle. Now they tell us that angle 2 is congruent to angle 3. Looking at our diagram, how do I know that angle 2 and angle 3 are congruent? How do I know that angle 2 and angle 3 are congruent? What do you think, Thomas? Say again?
It kind of just looks like it's across from each other.
What are angles that are across from each other like that called? What do we know about vertical angles? Yeah, so we can't go with the across from each other, so we just assume that they are, right? But we can go, oh, they're across from one another. They're vertical angles. Now we know they're congruent, right? So the reason that we can say they're congruent is because of the vertical angle theorem. On a test, I would take vertical angles or definition of vertical angles. Yay. Okay. So looking at the next statement, it says that angle 6 is congruent to angle 3. So as you go through, it's helpful to keep marking your diagram up, marking things on your picture. How will we know, the properties we learned on Wednesday will help you with this, how will we know that angle angle 3. What is the property we learned about? Is it the symmetric property? The reflexive property? The substitution property? The multiplication or division property? The addition or the subtraction property? Is it the distributive property? Is it the transitive property? Is it the segment addition postulate? What would it be? If we know that one angle is congruent to another, that angle, these two angles, 2 and 6, are congruent to one another. So 1 is congruent to 2, 2 is congruent to 3. So what do we know about 1 and 3? If 6 and 2 are congruent, and 2 and 3 are congruent, is there any way that 6 has a different measure? Let's put a number on it. Let's say, just for sake of argument, don't write it down. Let's say this is a 70-degree angle. What is the measure of angle 6? It says they're congruent, right? So if this is 70, what is the measure of angle 6? 70. So if angle 2 and angle 3 are congruent, what has to be the measure of angle 3? 70, right? So that is the transitive property. If two numbers are equal, and then one of those numbers is equal to another number, all of them have to be equal. Oh, it's already uncovered. That's the transitive property of congruence. So they gave you that one, but you are going to have to give that one because those two get together. How do we know that angle 6 and angle 7 are congruent? Helen? How do we know that? No, we don't know that, right? What kind of angles are 6 and 7 though, Helen? They're vertical. What do we know about a vertical angle? So if these are congruent, we use one arc. These are congruent, we use one arc. We're going to mark angle 7 also with one arc. So it's vertical angles again. And last but not least, how do we know now that angle 3 and angle 7 are congruent? What do you think, Charlie? Well, if we know angle 3 and angle 6 are congruent, and we know 6 and 7 are congruent, doesn't 3 have to be congruent to 7? What's that property called? Nope, it's a transitive property again, right? So if we know that 3 and 6 are congruent, and we know that 6 and 7 are congruent, so if you pick another number here, if this one's 80, that one has to be 80. If those are congruent, if 6 and 7 are congruent, this one has to be 80 as well. So it's that transitive property of congruence again. Okay, so it does not matter. Looks like a timer playing a board game flipped over on its side, right? These are two lines that are intersecting to create 4 vertical angles. You know, these two are congruent and these two are congruent by definition because they're vertical angles. They marked here, it says given, angle Y is congruent to angle ZXY. So this is angle Y, angle ZXY is congruent. They're telling us that, we're taking that as fact. So what are we going to write in the first statement? What are we going to write there, Analia? We'll go here. Yeah, angle Y, the given statement. So whatever comes after that word given, angle Y is congruent to angle ZXY. So this says that angle ZXY, so angle ZXY right here, right? This is angle DXY. It says it's congruent to angle VXW. So how do we know that those two angles are congruent? How do we know that DXY, remember that's how you figure out what they're talking about, trace the point, DXY and VXW. They're talking about these 2 points. Dallas, how do we know they're congruent? What kind of angles are they, Dallas? Not sure what they are. We don't know what they're measuring. Q by definition is less than 90 degrees. They look less than 90 degrees there. You can't really go by things how things look in geometry. You gotta go by how things are marked. So what kind of angle is formed by 2 intersecting lines, Dallas? Say it again? Yes. So these are across from one another. So we're going to mark them congruent, and the reason we're going to give is because they're vertical angles, and by definition, vertical angles are congruent. So now we're going to look here at the next statement. It says angle Y. So angle Y right here, it says is congruent to VXW. So how do we know that this angle and this angle are congruent? Xavier? Yeah. So this angle and this angle, yes. If it told us that these 2 are congruent, and now we know that these 2 are congruent, so that means that the first and the third one have to be congruent. Now this says angle Y is congruent to angle VXW. This says the measure of angle Y is equal to the measure of angle VXW. So we're talking about the same thing here, where the terminology is different. Replace the angle being congruent with the angle, the measure of the angles being equal. So that's just a substitution problem. That's like if we replace 5 with 4 plus 1, or if we replace 7 plus 3 with 10. It's just another way to say the same thing. So if they replace one statement with that same information, just written in a different way, then that's the substitution problem. What do you think the reason for statement 5 would be? What do you think, Ashley? What's the reason for statement 5? It says 2x plus 50 equals 5x plus 20. Any idea? Sorry? They are congruent, but why can we go from 4 to 5? Let's look at angle Y. How is angle Y marked on the diagram? So aren't those also another way to write the same thing, right? And angle VXW is marked with 5x plus 20. All 3 of these things, we made our way to saying the same thing, but that's how we have to do it in geometry. We can't just jump, right? Because here, this is the angle, not the measure of the angle, right? So that's another substitution problem. Now, how do we get from statement 5 to statement 6? So how do we get to go from 2x plus 50 equals 5x plus 20? Kianja? We are kind of combusting terms. If you mean, are we getting the variables on the same side? We are. What are we doing to get the variables on the same side? Elizabeth? Yes, we're subtracting 2x from both sides. Now, how are we going from step 6 to step 7? How are we going from step 6 to step 7? Zaria? Perfect. And when we do that, what are we going to get? Perfect. Because Zaria said to get from here to here is to subtract 20 from both sides. So we're already in the subtraction property. We have to know what that's equal to once we subtract it. What do we have to do to get from step 7 to step 8? What are we going to do to get from step 7 to step 8? Tori? What do we do here to solve, go from step 30 equals 3 times x to 10 equals x? We're dividing both sides by 3. I think that is our last example. So, does anybody need to go back to a slide? You can go ahead and stand and submit them. My new guys, Miles and Cecilia, the only thing that you need to get full credit for these parents, remember to write everything I wrote. So, if you are out, we'll send them back up so you can practice this part, okay? And then you can scan and submit them on your campus. Have we done that together? Can you log in yet? Okay. So, do you have the campus app on your phone? Or can you click on it? I'll do that. Okay, so then you have to use your Chromebook, so that's okay. All right, can you put the Chromebook, the app on your phone? One thing, we're scanning and submitting, and then we're going to start work on our worksheet. There you go, Jatavia.